Okay, lesson number 2 is using long division to divide a polynomial by a binomial. The purpose of learning division with polynomials is so that we can factor these polynomials. Because when we factor the polynomials, we can sketch the polynomials, we can determine certain aspects about these polynomial functions. So from grade 10, when we were dividing a monomial by a polynomial by a monomial, we divide each term by that monomial. So it's 15x cubed divided by 5x, 10x squared divided by 5x, and then 5x divided by 5x. I'll do it later. It's because I didn't do attendance. So 15x cubed divided by 5x would give me 3x squared. Negative 10x squared divided by 5x would give me negative 2x. And then 5x divided by 5x would give me 1. So when we do this, we have certain parts. We have the dividend, which is the value that I started off with, 5x, which is the divisor, and then the quotient is my answer. So then when I go to divide a polynomial by a binomial, it says if we were to divide 20 by 3. So if I divide 20 by 3, how many times does 3 go into 20? 6. So the dividend is my 20. The divisor is 3. The quotient is 6. And then I have a remainder of 2. So then I can write these division statements. And I can say 20 is equal to 3 times 6 plus 2. Or 20 divided by 3 is equal to 6 plus 2/3. So that 2/3 is taking the remainder and dividing it by the divisor. So then when I'm dealing with a polynomial, our statements become the polynomial is divisor times the quotient plus the remainder, or the polynomial divided by the divisor equals the quotient plus the remainder divided by the divisor. You won't be asked to memorize these statements, but if I say write it in this form, you will be required to remember what P, D, Q, and R are. And really the D and the Q, if you were to invert them, isn't going to make a big difference because when I multiply them together, I'm still going to get the same answer. So I just need to know the difference between them and the remainder. So if we look at class example number 1, a student used long division to divide 739 by 35 and wrote the division in 2 ways. So it says use this same method to divide 5,773 by 25, showing the result in 2 ways. So I will give you a moment to work on doing division in that style. Look at the example. Okay, let's review how we can divide without using a calculator. So when we're doing this division, it all comes down to place value. So we start off by chunking this 4-digit number into 1 or 2 or 3 digits. So if I look at it as 1 digit, 25 can't be divided into 5. So now I look at 57. So 25 goes into 57 twice. When I multiply it, I get 50, which gives me a remainder of 7. And then I bring down the other 7. So now I'm looking at 25 can go into 77 3 times. Multiply it through, I get 75. Subtract, I get 2. Bring the 3 down, and I get 23. 25 cannot go into 23, so this becomes a 0. 0 times 25 is 0, so I would be left with 23 as my remainder. So then if I wrote this result 5,773 is equal to 230 times 25 plus 23. Or the other way that I can write it is 5,773 divided by 25 will equal 230 plus 23 25ths. So when we start dividing with polynomials, we'll start off with our monomials first. If you are dividing with monomials, you're dividing each term by the monomial. If we were to set it up using our kind of division bars like we do for pen and paper division, is how I call it. I don't call it long division. Using the pen and paper division, the way that I look at it is x can divide into x squared x times. Or the other way to look at it is what can I multiply by x to get to x squared? I can multiply it by x. So if I multiply by x, the only thing I don't like is I put the x over here. I keep things lined up, so I'm going to line up my x terms. Okay? So x times x is x squared, subtract, and I get 0. So then I bring the 3x down. What can I multiply by x to get to 3x? 3. So then I go plus 3, and I line up the 3 with my 18, multiply it through, I get 3x, I subtract, I get 0 again, so then I bring down the 18. Because I'm at the end of my rows, I can't go on any further. And the other thing to think about is what would I have to multiply x by to get to 18? It's going to end up being a fraction, and we're not getting involved into fractions. So that's why I would stop. So if I write this in the form that the polynomial equals the divisor times the quotient plus the remainder, it means that my polynomial is x squared plus 3x plus 18, and that would equal the divisor, which is x, times the quotient, which is x plus 3, plus the remainder, which is 18. So it's little techniques that help you go through this. If you do the techniques, it just makes it a little bit easier. So again, if I look at x cubed minus 5x plus 6 divided by x, what do you notice about the way that it's written in here? So what's the difference between the polynomial written here and the polynomial written here?
Oh, the one inside the divisor sign is exactly.
Okay, but what else do I have in here? I have a 0x squared. Okay, so in my polynomial, I didn't have the 0x squared written in there, but I make sure to put it underneath my division bar. And that's because, again, I'm holding place values. So I have an x cubed, an x squared, an x, and then a constant. So if I had something that started off with x to the power of 4, I would want to make sure I have x to the power of 4, x cubed, x squared, x, and then my constant. Always making sure that I have something represented for each slot, even if it's a 0. And again, to make this easier, I would put the x squared above the x squared. So what I'm looking at is what can I multiply by x to get to x cubed? I can multiply it by x squared. X squared times x gives me my x cubed. When I subtract them, I end up with a 0. So then I bring down my 0x squared. What can I multiply by 0x squared to get to, or sorry, what can I multiply by x to get to 0x squared? I multiply it by a 0x. When I multiply that through, I get 0x squared again. Subtract, I get 0. So I bring down the negative 5x. What can I multiply by x to get to negative 5x? So then negative 5 times x gives me a negative 5x. I subtract, and I get 0 for that answer, and then I bring down the 6. And that's where I would stop, because up here with my quotient and my polynomial, I'm at the end. And if I'm trying to think of something to multiply by x to get to 6, again, I'm going to be looking at a fraction. So then my polynomial, x cubed minus 5x plus 6, would be equal to my divisor, which is x, times my quotient, which is x squared minus 5, plus my remainder of 6. And then when I look at 3, again, I'm going to move this 2x so that it lines up with the negative x. So if I'm looking at this one's a bit different because now I have a binomial. Okay? So if you look at the process, they have this 2x here, and then they got the 2x squared plus 4x. They get that by multiplying each term by 2x. But what I'm always trying to do is I'm always looking at the first term and how can I eliminate it. So when I'm trying to figure out why is it 2x, well, what can I multiply by x to get to 2x squared? I'm trying to eliminate that first term all the time. So I can multiply it by 2x, and that's how I get this statement. So then when I subtract, the 2x squareds cancel out, it equals 0. And I get negative x minus 4x gives me negative 5x. And then I bring down the 18. If I have two terms that I'm dividing by, I'm always going to have two terms here to bring down. Now, what can I multiply by x to get to negative 5x? Negative 5. So when I multiply this through, I get negative 5 times x, negative 5 times 2. So I get negative 5x minus 10 when I multiply that binomial by negative 5. I'm subtracting. So when I subtract, the negative 5x's will eliminate each other. And then I've got negative 18 minus negative 10 equals negative 8. So written in that form of p equals dq plus r, the polynomial 2x squared minus x minus 18 equals the divisor, which is x plus 2, times the quotient, which is 2x minus 5, minus 8. So when we look at class example number 3, it says divide y cubed minus 6y plus 20 by y minus 3 and express the answer in the following form. So we'll worry about the form afterwards and we'll look at the division now. So my divisor is what goes outside the division bar. And then the polynomial is what goes underneath. The key that I need to remember about my polynomial, it has to be written in descending order and I have to have every variable accounted for. So I'm starting off with a y cubed, which means the next thing that I need to have is a y squared. If I don't have a y squared, I put it down as 0. And it doesn't matter if you put it as minus y0 or plus y0 because it's still 0. So now we look at y cubed divided by y is y squared. So I'm going to put the y squared above the y squared, kind of keeping place value. Then I multiply it. Y squared times y is y cubed. y squared times negative 3 is negative 3y squared. And then I subtract. So y cubed minus y cubed is 0, it's gone. And 0 minus negative 3 is positive 3. So I get 3y squared, and then I'm going to bring down the 6y. And then I repeat the process. 3y squared divided by y equals
3y.
and it's a positive 3y, and then I multiply it through. 3y times y is 3y squared. 3y times negative 3 is
Negative 1, right?
and then again I subtract. And if I've done this correctly, when I subtract the first terms, the 3y squared minus 3y squared, it should equal 0. I'm trying to eliminate that first term. And then negative 6 minus negative 9.
Positive 3y.
Positive 3y. And then I bring down the 20. And then 3y divided by y.
3.
So then I multiply it through, and I get 3y minus 9. And then again, I'm subtracting. 3y minus 3y equals, and then 20 minus negative 9.
20.
And then I stop. And I stop because I have no other place to go after this point. Okay? So now when I write this in the form, the polynomial, which is y cubed minus 6y plus 20, divided by the divisor, and what's my divisor? Y minus 3 equals the quotient, and what's the quotient?
Y squared plus 3y plus 3.
Plus the remainder, which was
20.
over the divisor, which is y minus 3. And that's my statement. Okay. At the top of the next page, all they do is they change that division algorithm to be functions. So I have p as a function of x, q as a function of x, r as a function of x, d as a function of x. They still mean the same thing. The polynomial equals the divisor times the quotient plus the remainder. It's just now these could all be functions. They could all be polynomials in themselves, like in the previous question. If the remainder is equal to 0, it means that the divisor and the quotient are factors, because it means it divided evenly. If it's not equal to 0, then that means that they're not factors. Okay? The degree of the divisor cannot be greater than the degree of the polynomial. So if the degree of the polynomial is a degree of 3, the divisor has to be 3 or less. I can't have a divisor of 4. I have a degree of 4. The degree of the remainder has to be less than the degree of the divisor. So in those previous questions, the degree of the divisor was an x. The remainder had a degree of 0. Degree of 1, degree of 0. Degree of 1, degree of 0. This degree here can't all of a sudden be a degree of 2. Okay? That would be like if I divided on the previous page, if I had divided this and gotten a remainder of 28. My remainder can never be higher than my divisor, because otherwise I could have divided by more. Okay? So it says, class example number 4, consider the polynomial p of x equals 1 plus 5x cubed minus 4x plus 6x to the power of 4. Let's write this polynomial in descending descending order. So in descending order, what would be my first term?
6x to the power
Followed by
5x to the power 3.
and after 5x cubed,
Do we put like the 0x squared in now or after?
no, after.
Okay, then it'd be negative 4x
Followed by
plus 1.
plus 1. Okay. Now if I divide that polynomial by 2x minus 1, what would I get? So the 2x minus 1 is my divisor. It goes to the outside. And then I write my polynomial inside. And when I'm writing my polynomial, that's when I would include that 0x squared, Rachel. So 6x to the power 4, 5x cubed, 0x squared, negative 4x, plus 1. And then I start dividing. 6x to the power 4 divided by 2x. What do I get?
3x to the power 3.
So I put the 3x cubed above the 5x cubed, and then I multiply it out. 6x to the power 4 minus 3x cubed. And then I'm going to subtract. So 6x to the power 4 minus 6x to the power 4 eliminates. And then 5x cubed minus negative 3x cubed.
X cubed.
And then I bring, so 8x cubed, and then I bring down the 0x squared. 8x cubed divided by 2x.
Squared.
4x squared. This is why I want that 0x squared in there, because it holds that place value. And when I go to multiply it out, I get 8x cubed minus 4x squared. And if I didn't put that 0x squared in there and you would drop down the negative 4x, now you would be getting yourself into some confusion, because you have that minus 4x up here and the negative 4x squared down there, and you're more likely to just make a very simple mistake that you know you can't do. I subtract them. The x cubes are going to disappear. 0 minus negative 4. 4x squared. And then I bring down the 4x. 4x squared divided by 2x is 2x. Multiply it through and I get 4x squared minus 2x. Subtracting. So 4x squared minus 4x squared is 0. 4x minus negative 2 is negative 2x. And then I bring down the positive 1. Negative 2x divided by 2x is negative 1. And at this point, I should know this is my last step because I'm at the end of my statement. So negative 1 times 2x minus 1 gives me negative 2x plus 1. And negative 2x minus negative 2x cancels out. And 1 minus 1 equals 0. So now if I write this in the form, the polynomial in the division algorithm, I get 6x to the power 4 plus 5x cubed minus 4x plus 1 equals the divisor, which is 2x minus 1, times the quotient, 3x cubed plus 4x squared plus 2x minus 1, plus the remainder, which is 0, and I don't need to put that in. So then the next question, is 2x minus 1 a factor of this polynomial? How do I know? There's no remainder. If there is no remainder, it has to be a factor. So if we look at class example number 5, it says consider the long division statement. What is the divisor? What would d of x be? What's the quotient? And what's the remainder? How can I use these three functions to determine the polynomial? So how can I find out what p of x is? What would I do? So multiply the divisor by the quotient and then subtract the 2. So when I multiply this out, I'm using the distributive property. So x squared times 2x gives me 2x cubed. X squared minus 3, times negative 3 gives me negative 3x squared. 4 times 2x gives me 8x. 4 times negative 3 gives me negative 12. And then I subtract the 2. Collect the like terms. Two x